In this video, we are going to look at a few more ways in which you can use while loops to solve repetitive problems in a computer science program. So in our first program, we are going to see how to get a while loop to take in a list of numbers and tell us whether each given number is odd or even. So for example, I might type in a list of 10 numbers and I'd like it to output sequentially which numbers are odd and which numbers are even. Now the key to working with loops in general and while loops specifically is that you first want to imagine the problem without a loop involved, so you can get the logic straight, the thinking straight of what your program is supposed to do. And then once you do that, you want to wrap the loop around it. So instead of thinking of this as a looping program, I'm just going to write a simple program where I type in one number and the program tells me whether it is odd or even. So I'm going to create an int called num, and all I need to do is read in num, so get the system to read in the number that the user is inputting. And then I just need the system to check if num divided by 2, mod 2, gives me a remainder of 0. That's what that statement's saying. If I take num and I divide it by 2, is the remainder a 0? Is the mod a 0? Is what that question's asking. That statement is saying. So if it is, I want it to output, I want it to do a cout that says even. And then I'd like there to be an end line, and I'm going to end that statement. Here, you'll notice that I didn't put any curly braces, but I did indent cout. The indentation reminds me that this cout is part of the if condition. And the reason I didn't include any curly braces here is because it's a single line. If you have multiple lines, it's good to put curly braces so the program knows for sure what is included inside the if statement. But if there's just a single line after an if condition, you don't normally need to do that. Now to take account of odd numbers, I'm going to copy and paste that line of code again. And this time I'm going to say if the remainder is 1, I want the program to output odd. So this is how a single program would work. So let me run the program. There's going to be nothing on the screen because the system's waiting for me to input a number. I'm going to input 3 and it says odd, so it's working. Okay, now what if I wanted this program not to run once, but run as many times as I needed it to take in an entire list of numbers? That's what we're going to discuss. So really all that we need to do is we just need to say that this program needs to run as long as I do not enter a particular number, which I can decide. So I want to say as long as I don't enter, or as long as the user doesn't enter -1, keep going, keep taking in numbers, because I want you to work with all of them. So the way I write that is while num is not equal to 1. While num is not equal to 1, as long as the number that the user is inputting is not -1. I'm sorry, let's make that -1 so we can deal with positive numbers. As long as it's not -1, do this. And then whatever I wanted to do, I put inside these curly braces. So now as long as I don't input -1, it should continuously take in numbers. So the way this works is if I run this, if I, let's say, put in a few numbers, 2, 4, 7, 13, 9, and then let's say I'm done and I put in -1. Now, what happens when I hit enter is the program reads the first number and then does its calculation to see if it's odd and even and prints it out. Then it reads the next number and does the same, and then it reads the next number and does the same. And the way it knows what the next number is because of the spaces in between. So the spaces tell it, okay, that's the end of one number and the beginning of another number. But it happens so fast it feels like it's happening instantaneously. The program doesn't execute until I press the enter key. That's when it begins to take in the numbers, process them, and output them. But of course, the speed at which that's done is almost instantaneous, so it feels like it's happening right away. So I'm going to go ahead and press enter on this side of the screen. And as you can see, it gave us the correct response to all of those numbers. Now, the math that you can do inside a while loop is all sorts of math, not just odds and evens. Let's say you want a number to be squared. Let's say you want the user to enter these numbers, but instead of telling you if they're odd or even, you just want them to be squared. Then of course the math here will change. You will say something to the effect, cout num times num, and it'll square it for you. What if you did not want to use all the numbers that the user entered, only a few of them? Let's say you were only interested in the first 3 numbers that the user enters and not the rest of them. Well, what you could do is you could set up a condition inside the while loop that specifically says only take so many numbers. So the way you would do that is in your loop, let's say we're only interested in taking the first 3 numbers and figuring out if they're odd or even. You would set up a counter that would keep count of how many numbers have been inputted. So I'm going to set up a counter, which is going to be an int. And every time a number is read in, right after that, I'm going to get the counter to add 1 to itself, which is what this means, counter plus plus. So what this statement is saying is as soon as you read a number, add up to the counter. As soon as you read a number, add up to the counter. Now what I wanted to do is I wanted to stop executing this if we have exceeded 3. Okay, if we've already read 3 numbers, I don't want it to read anymore. So the way I do this is I set the counter to 0. So when the first number is read, the counter will have updated to 1. When the next number is read, it will have updated to 2. And when the next number is read after that, it should update to 3. So once the counter is 3, I don't want it to run the rest of this code anymore. I want it to ignore the rest of the numbers. So the way I do that is I put another if condition that says if counter is less than or equal to 3, which means if it's a 0 or a 1 or a 2 or a 3, keep going, keep executing the program. But once it exceeds 3, do not run the rest of the code or stop. So now I'm going to put curly braces and put the rest of my instructions inside those curly braces. So now what's going to happen is the counter will only take in the first 3 numbers. It'll still read the others, but it won't execute anything with them. So let's try this. So I'm going to put in 1, 2, 3, 4, and 5. And all right, that's a bit of a lag in the program. 5 numbers, and then I'm going to say I've ended the program by putting in -1, and as you can see, it only processed the first 3 numbers. Now let's talk about what to do in more complicated questions that require more than one loop. So let's say we have a program that gives us 5 digits, or 4 digits, 0, 2, 4, and 6. And the program says, how many 2-digit numbers can you come up with by combining 0, 2, 4, and 6? So you could, for example, come up with 20, 22, 24, 26. Then you could update that to 40, 42, 44, 46, and so on and so forth. But you want the program to do that. Now this is going to require 2 while loops. And let's look at why that is going to be the case. Once again, we want to think very, very simply. Let's say I just wanted to output a 2-digit number very simply. How would I do it? Well, you'd create an int called num1. So we're not thinking about loops right now because that'll make it complicated. We're just thinking of the logic, then we'll wrap the loop around it. So I've created 2 ints, num1 and num2. And if I just do a cout on num1, followed by num2, followed by an end line, and if I give these nums some values, like if I call that 2, and if I call that one 0, and of course if I run the program, then it's just going to output that number. Okay, so you want to think very simply, how do I take 2 digits and put them together and output them as a 2-digit number? This is how you would do it. Now let's think about, well, how do we make these digits change? So the first time it prints 2, 0. The next time I want it to print 2, 2. And up here, commenting it out, I'm going to put down the set that we have, 0, 2, 4, and 6. So this is our set. So we want all sorts of combinations from this. So let's say we outputted the first combination, which is 2, 0. And the next one, I want it to be 2, 2, then 2, 4, and then 2, 6. Of course, we could just do a whole list of couts, but that's going to get very tedious, and plus we want the program to do all this hard work for us, not ourselves. So one of the things you would do is, as you can immediately see, num2 is currently 0, but you can get num2 to add to itself, so that on the next line you can say, I would like you to update the value of num2, so the new num2 becomes the old num2 plus 2 more. This is how you'd read it. The new num2 should be equal to the old num2 plus 2 more. So since the old num2 was 0, on this line, line 10, the new num2 is going to be updated to 2. Now, the question is, we've updated num2, but how do we get it to print again? So as you can see, this is where we want our program to loop back to line 9. And the way to make something loop back, of course, is to put the whole thing inside a while loop. So now I'm going to put a while here, and I'm going to put curly braces. And what that's going to do is, right from at the end of line 10, the program is going to loop back up to line 8 because we've put it inside a while loop. The only thing is we need to tell it when to loop and when not to loop, when to stop looping. So the way to figure out what to put in there is you say to yourself, well, how long do I want num2 to keep updating itself? And as you can see, we want num2 to be updated to up to 6, but no more. So we don't want an 8 in there because it's not part of our set. So the way you express that mathematically is you say keep going while num2 is less than 8. As long as num2 is less than 8, keep looping. So if it's a 6 or a 4 or a 2, keep looping. Another way you could have written this is you could have said while num2 is less than or equal to 6, which does the same thing, but it includes 6 in it. So now let's go ahead and run this and see what happens. So now you can see our loop is working and it's printing 2, but now the second digit has been updated to 2, 4, and 6. So far, so good. Now the question is, okay, this is good, but how do we get the first digit to update? And as you can see, the first digit is num1. So we want num1 to stay as num1 for the first 4 loops, but then after those first 4 iterations, we want it to update to 4 and then update to 6. So the way we do that is we say that as soon as this loop is finished, this inner loop that ends on line 11, as soon as that is finished, which it has right now, then we want num1 also to update to num1 plus 2. Okay, so we want num1 to update, but we want it to do once num2 has done its job. Again, how do we get this to loop right all the way back to line 7 here? We put in another while loop. Okay, we'll come to the condition in a minute. We put the curly braces and we put our entire code in a loop, and we say we want num1 to update as well. Again, now you say to yourself, well, how long do I want num1 to keep updating? I don't want it infinitely because the program will just crash and it won't stop. And again, the biggest number that we want num1 to take is 6, no more than 6. So now you will say while num1 is less than 8 or greater than or equal to 6, I want this to continue. Now, our program looks like it's ready to run, but if I run it, you'll see we're going to hit a problem. So, you can see that the program has updated num2, but it hasn't updated num1. Now, this is where a very common mistake happens when you're programming these for the first time. One of the things that you forget is once num2 has done its job and it's changed from 0 to 6, it's stuck at 6. So if you want the loop to run again, because there's a condition here that says num2 must be less than 8 to run. If you want it to run a second time or a third time, when it's finished running and it's ready to run again with a new value for the first digit, you must make num2 back, restore it back to its original value. So down here at the end of the loop, I'm going to say num1 should be equal to 0. num2, I'm sorry, should be equal to 0. So here, what I'm saying is the second number should be equal to 0, and then the first number should change its value. So what does this do? The next time the loop runs, num1 is going to update to 4, and num2 is going to start at 0. If you don't put this clause in, the program gets stuck. It doesn't realize, it doesn't know how to update because it's stuck on this condition. So you have to help it restart and get over that condition by making num2 a 0. Now let's go ahead and run it again. And there we are.